Hello YouTube. So today I'm going to be going over how to insert into a heap. But firstly, let's recap on what a heap is. A heap is a binary tree data structure, and there are two kinds of heaps. The first of which is a min heap, which has the property that every node is smaller than its children. And the second is, of course, a max heap, which you can probably guess has the property that every node is greater than its children. This means that for a min heap, the root node is the minimum of the entire data structure, and for a max heap, likewise, the root node is the maximum of the entire data structure. So how do we insert into a heap? Well, the first stage of insertion is to find the last row, and if it's incomplete, insert into the leftmost free location. If there is no incomplete row, then we start a new row, giving the leftmost child of the previous node a new left child. That is, starting a new row at the leftmost location. So in this example, with this heap, we'd insert the new node into the right child right here. The second stage of insertion is, of course, we have to make the heap a valid heap. To do that, we swap the new node that we just inserted with its parent until the heap's valid. So for a min heap, we'll swap this new node with its parent until its parent is smaller than the new node. Likewise, for a max heap, we'll swap it until its parent is larger than this new node. Now let's go over a quick example to show how inserting into a heap works. So for this example, we're going to be inserting 5 into this min heap. Now the first step is to find the bottommost row, which is this row. We see that it's incomplete, and we find the leftmost available location, which is the left child of 10. So we insert the 5 here, which ensures that this heap remains perfectly balanced. Now we see that the 5 is less than 10, which means that this is not valid, so we swap the 5 and the 10. Then we see that the 5 is less than the 7, so we swap the 5 and the 7. And now we see that the 5 is not less than 2, which means that the entire heap is now valid and the 5 has been successfully inserted. Now, to analyse the worst case complexity of this, it's fairly straightforward. We see that the worst case scenario of inserting into a heap is if we're inserting an element that would then become the new root. To do this, we must swap the new element all the way up to the root, which means we must swap it the height of the tree times, which means that the complexity is equal to the height of the tree, which is equal to log base 2 of n, where n is the number of elements in the tree. So the complexity of inserting an element into a heap is log n.